This is a slightly longer introduction to the more advanced capabilities of the Spitzer Heritage Archive. From the IRSA homepage, click on Spitzer, and then go to the Spitzer Heritage Archive. From here, by default, you're dropped into a position search. I covered position search basics in an earlier movie, and that's probably the most common search that people do. You put in the search target, select the search radius, and select the tabs you want in the output. You can put in a name and pick which service you want to attempt to resolve the name, or you can put in coordinates in any of a variety of units. When you put in a target, you can see that it resolves the name below the box so that you can check that it's understood you correctly. Next, a search radius. If you want to change the units first and then put in the number. If you put in the number first, then it changes the number to reflect the change in units. Then choose the search results that you want. An astronomical observation request, or AOR, is the fundamental unit of Spitzer observing. I recommend that you always leave that checked because that is the most compact way to view Spitzer observations. Level 2 or post-BCD, PBCD, results are the highest level products produced by the Spitzer pipeline. They're produced on an AOR basis, and I recommend that you leave that checked too, because if you're looking to see whether or not the observations here are relevant to your work, this is going to include mosaics and extracted spectra, so it will be easiest to tell if the data are relevant for your purposes from the Level 2 data. Level 1 BCD data, that's output from the pipelines, but those are individual frames. They're not combined mosaics or extracted spectra. You may want to return that for your searches. Then these 3 tick boxes are extracted products that involve more than one AOR. IRS enhanced products are data products produced by the IRS team at the Spitzer Science Center, and SEIP is Spitzer Enhanced Imaging Products. Those are data products produced, again, by the teams at the SSC. It includes only cryogenic era data, but it combines all of the available cryogenic era data for all of the available AORs for a given position on the sky for the 4 IRAC bands and MIPS 24, and it extracts the sources down to a given level. So before I actually do a search, let's review some of the other searches that you can do. You can do a multi-object search. If you have a list of positions, you can put in that list of positions in IPAC table format, which is just basically plain ASCII. Upload that list to the tool here, and then it will give you a list of all the observations within the radius that you specify for all of the positions in your list. The other default tab that you have here is Search by Solar System Target. There are many targets that Spitzer observed where it tracked with the moving target, and that is what is meant here. You can put in the target name, like Neptune, and then you have to wait a couple seconds. You have to give it a chance to talk to the database, and then pick the NAIF ID that you want that corresponds to that target. Under the hood, everything is tied to that NAIF ID. If you just put in the name, even if it's a famous name, that's not enough. Then, again, you pick the tabs that you want in the results. Now remember, these are observations where Spitzer was deliberately tracking on the target. It knew it was observing a moving target, and it was tracking on that target for that observations. But there are plenty of observations where it could have just happened to catch a moving target in the process of doing something else. In order to find those observations, you have to use a different tab. If you go to this icon here, which is sometimes called a hamburger, you can find additional tabs for many different additional searches. For this, let's pick Precovery. This kind of search looks for serendipitous observations of a moving target. Here you can put the name like Karen, and then you have to give it a second to go find the NAIF ID, and you pick the NAIF ID. Then you need to tell it a range of dates. What it's doing when it does this kind of search is it goes using the NAIF ID to find the orbital parameters for this object. Then, given the orbital parameters, it is calculating where this object is over the time that you specify, and then looking to see if there are any serendipitous observations of this object that happen to be carried out with Spitzer. If you put in a long range of dates, this calculation can take a long time and, importantly, not be accurate. You can understand if you extend over a very long time baseline how those calculations might be increasingly inaccurate with time. Once you start having non-Newtonian forces, for example with comets, that calculation gets increasingly inaccurate. So you do have to be a little bit careful with exactly how you do the search. And moreover, if you do it over a very long time baseline, it can take a very long time to actually execute the search. If you do want to play around with the orbital parameters, you can put in a one-line MPC input for the orbital parameters, or you can individually put in the orbital parameters here. You can then calculate the orbit for the dates that you specify and then have it go look to see if there are any Spitzer observations covering the relevant part of the sky at the time that you're asking it to search. Let's continue to look at some of the other searches. Recall that an AOR is the single Spitzer observation. An AOR key is a large integer that uniquely identifies that observation within the Spitzer database. So using this search, you can find specific observations. Spitzer operated autonomously with one instrument at a time for up to 2 weeks in campaigns. Every one of those campaigns had a name that had the instrument and then the numeric ID. You can find entire campaigns using this kind of search. You can also search by observation date. Aside from the obvious use case of finding observations that you know were taken on a particular date, this also can be used to find out whether or not there was an observation that could have impacted a later observation. So for example, if you have your observations and you see something in the image that might be an artifact, you can look to see if there was a very, very bright observation that was taken 30 minutes before your observation, for example. Or if you are someone who studies solar activity, you can look for observations that were taken after a particularly bright solar flare and look for any impact on the observations. You can also search by observer name. You need to put in the observer and then pick the observer from the list that it gives you, and then go search to find all of the observations corresponding to that observer. All of the observing programs had a numeric ID and a string that goes with them. And you can search either by the program name or the numeric ID. And when you do this kind of a search, it retrieves all of the observations associated with that program. Some programs had more than one program ID or program name. It just depends on how big the program was and what made sense in terms of how to divide the observations among those program IDs. You can also search by abstract text. So for example, if you're interested in planetary nebulae, you can put in the string and it gives you then a list of all of the programs that it can find that have that string in the abstract. It does do a little bit of fuzzy logic in doing that kind of search, but once you look through here and find a program that you're interested in learning more about, if you click on the program name, then it rolls over into a search by program and then loads all of the observations for that program into that tool. The rest of the searches here are additional non-Spitzer searches that will make more sense once we get some more results into the tool. So I'm going to reset all of the tabs and go back to the search by position. This time I'm going to put in M16 with the default radius, and I'm going to click all of the tabs search. All of the results for all searches go into the results tab here. It comes back with one tab for each of the tabs that you requested. Over here on the right-hand side, it gives more information that changes corresponding to what row is selected on the left. The thing that's in the foreground here by default is something called depth of coverage, where it gives you a representation of how many frames there are on the sky as a function of position. However, it is actually more useful to go to the data coverage tab. When there are many tabs on the left, the data coverage tab sometimes takes a couple seconds to load. So this is a representation of everything that it found. All of these polygons represent the footprints from the post-BCD products, the level 1 products, the IRS enhanced products, the super mosaics, and the source lists. It's all overlaid on that 2-mass HIPS image in the background. If you want to change the colors, you can click on the swatches that are here and pick another color. Or you can go to the layers icon here and change the color and turn the layers off and on. If I zoom in here really far, you can see that there's quite a few things overlaid in the heart of M16. Let me zoom out a little bit and then go back over here, and I'm going to turn off the source list and the BCDs just to make it slightly easier to see. Over here, I'm on the Post BCD tab. And now what I'm going to do is I'm going to filter this down so that it's only the Iraq data. Now you can see that there are many fewer of these dark red polygons here on the right. You can see that there's only Iraq mosaics, and depending on which row here that I'm clicking on, a different one is highlighted in orange. It works the other way too. If I click in the image, then that row is highlighted on the left. If I go to the data preview tab it shows me a preview of that data that's selected here on the left. Note that the source list is also overlaid on the mosaic. Note too that what it's doing here is showing the catalog in a hierarchical catalog display. If I zoom in, it will eventually show me the sources, but if I zoom out, it's showing it in these tiles. Let's go back to the data coverage tab, and let's go back and turn the source list back on over here. You can see the tiles are there too. So what's going on is that because in the source list there's 3,500 sources, rather than trying to put all the individual sources on the image, it's showing it in bins. If you zoom in far enough, it does show the individual sources, but if you zoom out, it shows it to you in these cells. If you click on the cells, it will show all of the sources in the cell. But when they're in the cells, it's giving you a number, like there's 15 sources in this cell, there's 29 sources in this cell. You can control that from the layers. You can change how it's showing you those cells, how many sources there are per cell, and how big the cells are, also the colors that it's using. So you have some control over that. It basically is trying to not bring your browser to its knees, because if you have thousands and thousands of sources overlaid, it's going to slow your browser down a lot. Let's go back to the level 2 tab and cancel the filters there. All of the polygons will come back. You've already seen me using some of the tools for the images over here. You've already seen me using the layers icon. There's lots and lots of really sophisticated tools that are here. Let's go over to the data preview tab. You can see that this is a fits image. I can change the color table of this image. I can change the color stretch of this image. There's a lot of other things I can do too. I can measure things on the image. I can also extract a line from the image. Like if I draw a line across the image, I can see what the fluxes along that line look like. Let me cancel out of that. So there's other movies that go through what all of these tools do. There's a lot of really powerful tools actually that are available. Similarly, over here on the tables, you've seen me use some of these features already. You've seen me use the filters. That's another really powerful thing. There's other things you can do here, and there's other movies that talk about this as well. Let's go over to the source list. One of the tools that's here is you can add a column. So if you want to calculate a column, you can add a column that calculates values from other columns in this table. You can, for example, you can add a filter on the fluxes. Let's add a filter that requires that there be a flux from IRAC 1 and aperture 1 and IRAC 2, aperture 1, and IRAC 3, aperture 1, and IRAC 4, aperture 1. Now I have only 418 sources. I'm going to add a column and say hi SNR here. I'm going to use a preset function, set filtered rows to true and the rest to false. Add a column. Now I have a new column, so that even if I cancel that filter, I still have a column that lets me know which rows were true when I imposed that filter. There's other things you can do with the source list. There's a chart over here. Now, for some of these tabs, the chart seems very strange because the chart in those cases is literally just a chart of the reference pixel for the images, which is kind of boring. But the source list, that can be very powerful. So by default, it's plotting RA index because it knows that the source list is going to have an RA index. So it's a safe default for a plot, but we can change what's plotted. Instead of RA, let's use IRAC 1 F aperture 1. And then for Y, let's do the error in IRAC 1 aperture 1. And let's make it a log plot. Apply, close. There's a plot of the flux in aperture 1 for IRAC 1 against the error. So you can make sophisticated plots from the catalogs that you have loaded. The IRS enhanced products, if you go to data preview, it's a spectrum, but this is also a plot. Because the tool understands that this is a spectrum, it has done some sophisticated things. It understands that there are 4 orders in this spectrum and has plotted them in different colors. It's added the errors. And moreover, if you go to try to change what's plotted, you have different choices because it knows that it's a spectrum. You can add a redshift, and you can change the units of the spectrum if that is what you would like to do. I mentioned that you could do some searches for solar system targets. This is an example of a search for a precovery, in other words, serendipitous observations of the asteroid called Charon. You can see here that it's calculated an orbital path for this asteroid over a relatively long time baseline. You can see it going retrograde. Actually, I guess it's starting over here, going retrograde and coming over here, going retrograde and coming. So what it's done is it's calculated the orbital path for the time that I specified, and it's found a handful of serendipitous observations, some here and some there. So if I go over here, then I go to data preview. This is different. This is a different view than you get with the other searches for inertial targets, because this is a moving target and it knows that you've done a search for a moving target. It's showing you the individual frames, and in each case it's highlighted for you where it thinks this moving target falls on these individual frames, and there are 32 frames that it found for this object. So here again, it's trying to help you understand whether or not the data that you find is worth downloading. How do you download data? Well, for either moving targets or inertial targets, it's the same idea. You select the rows that you want. If you want all of the rows, you can select the tick box at the top and then click Prepare Download. Depending on where you are when you initiate that request, you may have different choices. In this case, it only is giving BCD, calibration, and raw data products as a choice. If I go over here to the AOR level, pick an observation and prepare download, then it gives you different choices. If I go to the level 2 post BCD tab, again, pick a row and then prepare download. It's giving me choices of level 2, level 1, calibration, and raw. If I initiate this request from the Super Mosaics tab, I will have different choices because it has different data that are included. If you want to save a catalog like the source list, what you do is you just use the diskette icon here, and you can save it as an IPAC table file or any of a variety of formats. For all of these things, you can save it to your local disk, or you can save it to the IRSA workspace. In the context of a table, you can save the table as displayed. In other words, in this case, because I've added a column, it will save that additional column, or you can save the table as originally retrieved. One last thing I want to show is this icon here. I think of it as sort of an action icon. It's supposed to be like a microscope, but you can launch additional searches. You can do additional things. Some of those additional searches are the same kind of searches you get from over here. If I go to the Catalogs tab, this allows me to search other catalogs at IRSA. I have to select a project first, then a catalog. I can tell it what kind of search I want, and then I can launch the search, and then the results will show up in the Results tab. I can also do a data collection search. This is particularly useful for Spitzer programs because there are so many Spitzer programs that deliver data back to us here at IRSA. There are a lot of really, really, really rich data sets. So especially if you are looking for Spitzer data to get up and running with, there's lots of data that are delivered back, ready to use images, catalogs, spectra, phenomenal amounts of data, sometimes even data products that are beyond Spitzer's wavelengths. So I encourage you to take a look at these additional programs. If you want to learn more, you can click on the eye with the circle to learn more about the individual programs that deliver data. And of course, you can also take advantage of the additional programs, say from Herschel or some of these other observations that we have here that might also have data that you're interested in using. VO TAP. VO is the Virtual Observatory. TAP is Table Access Protocol. This is just another way of getting access to tables. In this particular interface, this particular tab is accessing IRSA tables. So it's the same catalogs you get from the Catalogs tab, except that you are using the VO TAP services. If you are fluent in ADQL or learning to be fluent in ADQL, you can use the GUI to design the query, then populate and edit ADQL. Then you can get ADQL query here, which you can copy into your Python code, for example. Here, you can also do a NED query, and here you can do a multi-archive VO TAP search. So you need not be confined to the IRSA TAP service. You can choose a variety of other services, including CADC, which also has OBS-TAP searches. If you're familiar with what these are, this basically goes out to the virtual observatory and finds data from all over the rest of the world on any given target. For all of the things within this tool, there's online help. Don't forget, there's online help and also context-sensitive help in many cases with lots more information about all of the things that you can do with this tool.